Wow. Shall we get started? Good afternoon. I totally feel like a rock star, with this mic and the theater. It takes me back to school days when, you had a lot of people, your parents, and then you're performing in front of them. It's a nice theater. So welcome to today's session. We're going to talk about network performance and management. My name is Prabhu Rambhadran. I'm a product marketing manager in the Windows Server and management team. So they keep switching our titles. It was technical product manager, so I'm not a hardcore marketing person. I'm more on the technical side of marketing. So the agenda for today, we'll have a quick introduction, and then we'll spend about 5 to 10 minutes on network management. This is just to let you know about a couple of new features that we've added in network management. We will not be diving into detail here. There are a couple of sessions that go in depth regarding network management. I'll point you to that, but there are a couple of features that I think most of you would be interested in, and I wanted to bring it up here. And then we'll spend a lot of time talking about performance, right? Talking about performance is always tricky. You have a set of people who think that, it's way too technical, and you have a set of people who think, I'm just blowing smoke here, that, this is just too high level for me. I don't know why I'm spending my time here. So depending on who you are, you might really like the session, or you might just not like the session at all, right? But I've tried to set context before I get into any specific topic as a part of this presentation so that most people sitting here could relate to what I'm talking about. Before I jump in, if you don't mind, can I have a raise of hands? How many of you here are IT professionals? Vast majority of you. Network administrators? Few of you. How about developers? Couple of you there. Decision makers? No one. Wow. So I think I have a little bit for all of you here. So without much delay, let's just jump in. So it's just the second day, so I'm going to spend a couple of minutes on this slide. Had this session been on Friday, I wouldn't even be going through this slide. But I promise you, by the time it's Friday, you'd be really bored of this slide, because you'd have seen it in all Windows Server sessions. Anyway, just to quickly summarize what the slides talk about. So every time we start planning a new product, right, we spend hours and hours, thousands of hours working with customers, just sitting in server farms, looking at how people use the product, listen to what they're complaining about, what they like, what they don't like, and then working with our planning team to see where the market is heading, what are the features that customers really want, how do we bridge some of the products that we already have. A lot of planning goes on. And then we decide on what we call pillars. And then each of the features that we develop for the product maps to a specific pillar. So for Windows Server 2012, these are the pillars that we landed with. The first one is beyond virtualization. So virtualization has been there for almost 10 years now. All of us know and have heard about Hyper-V virtualization. It's gone to an extent that most people are still finding the best way to make use of it, right? The number of VMs that are supported, the size of virtual disk for each of these VMs. It's making rapid strides. But we've reached a point where a lot of customers are looking beyond virtualization. They're thinking about private cloud, right? I mean, how do I expose my virtualized resources to my end users, be it my customers or people within my organization? They're thinking about public cloud. How do I move what I have on-premise to off-premise? And there'll be a period of time when they'll have something that's on-premise and something that'll be off-premise. And they need to be connected to each other so that you have a seamless experience, right? So we see a lot of customers thinking beyond virtualization. The next pillar is as more and more devices infiltrate into the market, as more and more web applications come in, the number of web servers, the number of servers that you typically have starts growing, right? So most people don't think about, for every smartphone that comes in, For every 500 phones that people end up buying, there is a server that gets bought to. So think about all the new servers that people now have to manage. So you need more functionality in each server to meet the demand, and you need a more faster and efficient way to manage these servers, right? So you want to manage all your servers as if you're managing just one server. So that's where, all our investments in Server Manager, a very strong infrastructure with PowerShell underneath, giving you the ability to automate every task that you want to do so that you don't spend time just doing the same task over and over again, but just spend some initial amount of time automating all your regular mundane work and then do whatever is the most important to either your career or your business, right? The next one is every app, any cloud. Like I mentioned, you have your public cloud, your private cloud, your VM sitting here, your VM sitting there. Finally, it's all about the app, right? Your app needs to be up and running. And for that, you need a very strong foundation underneath so that both building and maintaining your app is easy. And the last thing is the modern work style. Just take yourself back to 2002, 2003. Think about how you accessed resources that you need for getting your work done. There are no smartphones then, there are no slates, there are no tablets, there are no laptop, very few laptops. But think about how you're accessing work information now, right? You're connected to your colleagues, your work environment pretty much all the time. So the server underneath needs to support this kind of flexibility. So these are kind of the broad level pillars that we came up with. And the topics that we'll be covering falls under the first two pillars. So what do I want you to remember when you walk out of this hall, right? Number one, I want you to know a couple of new management features that we've added with Windows Server 2012, right? And you need to know which session you need to go to understand more about those two features. Then you need to understand about the performance features that we've added in Windows Server 2012 that improves your network performance, basically. And then you know about tools that are available in-box and out of the box to help you diagnose problems when you run into performance issues in networking. And finally, you have a few takeaways which will help you fine-tune your hardware so that you get maximum performance. Let's jump into network management. These are the two features that I wanted you to be aware of. The third one is PowerShell. So by the end of this week, whether you remember your wife's or your husband's or your child's name, you'll remember PowerShell, right? We're going to talk about PowerShell so much that you'll never forget it. But it's that important. So I was in TechEd North America, and a customer stopped by and said that for him, PowerShell is, catch the boat right now moment. Learning PowerShell is that important. You miss the boat now, you're going to pay for it later. So I would strongly urge you to spend a lot of time with PowerShell this week and over the next few months, trying to understand all the capabilities that it provides and get yourself familiar with it. I don't have specific slides about PowerShell just because of how much you would learn about it this week, but I've given a lot of PowerShell-related examples throughout the deck. First one, resource metering. Any service providers here? Few of you. And the rest of you, do you have any kind of showback mechanism built where you let your HR department, your engineering know that you've used these amount of resources? Is there a need for building a solution like that, where you want to better understand how your resources are getting used? So resource metering would let you do it. With this feature, what you could do is get better understanding as to what kind of resources and how much of those resources each of your VM uses, right? So I've listed a whole bunch of metrics that you could track that's getting used by a single VM or a bunch of VMs. So what you could do is when you create your VM, you could turn on resource metering, and you could start watching multiple metrics that you want to monitor, and then build a chargeback solution at the end of the month, right? So whether it's a single VM or multiple VMs, you now have the ability to better understand what kind of resources it uses and how much it uses. And at the end of the month, you could charge back to your customers saying that, this amount of CPU was used, this is the storage that you used, this is the network bandwidth that you used. And it provides a lot of additional functionality too, right? Not only does it let you understand the network traffic, but it'll also let you differentiate intranet traffic versus internet traffic. For example, you want to just do a showback, which is just send a report at the end of every month saying, this is what engineering team used, this is what development used, so on, right? Or you could actually build a chargeback solution and send it to your customers at the end of every month. Like I said, the biggest advantage is providing a solution to keep track of what kind of resources you used. The good thing is, no matter where your VM stays, let's say that the beginning of the month, your VM was in a particular subnet. After that, that particular application had to move to another subnet, and the VM moved with it. The chargeback that you started or the monitoring that you started will continue. And the process is pretty simple, right? So when you create the virtual machine, you use PowerShell to just turn on resource metering. I've listed the PowerShell commandlet that you could use. And then at the end of the month, you could just run a report, and it'll give you in a lot of detail as to what kind of resources you used. You could turn on, turn off different metrics depending on what you care about the most. This is a handy little feature. It not only helps you with chargeback solutions, but also with planning, so that you know how many VMs or what kind of resources you want to allocate to different departments within your company. And this is a feature that became really, really popular because a lot of people liked it. And they liked it because it's now shipped in box. IP address management ships with Windows Server 2012 now. Again, raise of hands. How many of you use third-party solutions to manage your IP address lifecycle? Okay. How many of you use in-house tools, scripts tools that you wrote? And how many of you use spreadsheets? You don't have to lie. The rest of you could raise your hands too. From what we've heard, 60% of customers still use spreadsheets, right? Each of these solutions have their own advantages and have their own disadvantages. For example, third-party solutions, they work like a charm for most of you, right? They integrate really well with Microsoft's DNS and DHCP services. So you get up-to-date information about your devices, about what kind of allocation you've already done. But the biggest disadvantage is that in addition to paying for your server, your applications, your clients, you also pay for another solution, a person who takes care of your IPAM servers, and then there is capital expenses when you acquire the software, and then there is maintenance that you have to pay for. Your in-house tools are great because there is no additional expenditure, but there is a lot of tribal knowledge, right? When you leave the company, a lot of information that's associated with that particular tool is lost now. Then you need another person who needs to train it. And then we spoke about expanding to different clouds, right? These tools don't scale up really well. And the final thing is spreadsheets. I've listed a $10 per address per annum. I got it from the team. I don't know how they managed to pull a number like that, but apparently that's how much people spend just using spreadsheets. I mean, spreadsheet wasn't designed to maintain IP addresses, right? It's a handy tool, but it's not meant for that. And you end up spending a lot of time. It's not dynamic. It doesn't, every time you change your configuration, you have to go back to your spreadsheet and update it. So we'll do a quick overview of IPAM. So IPAM lets you do address space management. So you can create static address blocks, carve out IP address ranges from that, and then start assigning IP addresses from that point of time. It'll do automatic network discovery of your DHCP, your DNS, your domain controller, and import information from there. And from that point of time, you could manage and monitor dynamically allocated IP addresses as well. And lets you manage your DHCP and your DNS servers from within the IPAM screen. And finally, it gives you excellent information that helps you a lot with audit. This is something that a lot of customers have asked us for. They want to understand how the IP address moved over a 1-year period, over a 6-month period, how a device moved from one network to another, and finally build up reports based on that. So it gives you excellent visibility and audit into how things are running now and how things ran in the past. So it complements, because it's a Microsoft solution, it's built in-box, and it works really well with Microsoft's DNS and DHCP server. So what all does it include? So you have the IPAM server that's shipped in-box now. IPAM relies on the SQL C server that's available in-box too. That's the database that it's going to use. You typically manage your IPAM server just like any other server with an RSAT tool that's exposed through another Windows server or a Win8 client. Your IPAM server talks to all your DNS, DHCP servers. It does agentless monitoring, so there is very little performance hit because of that, and gets all the latest information from all these servers. And it provides flexible user roles, right? You can assign different users to perform different actions. For example, you can create, you have your IPAM administrators who have control over everything. And then you have your address space management administrators who just can create IP ranges and then assign it to different machines or create IP blocks and then reserve it for the future. And then you have your server management administrators who have access to your DNS, DHCP servers. And then you have your IPAM users. And at the end of the year, you have those auditors who want to understand where the system moved and try to get some forensic data out of it. So you have a specific user group just for them. IPAM also supports failover. So you can have multiple IPAM servers across different geographic locations. They could either be active-active or active-passive. And finally, it integrates well with external systems. So you could, any operation that you perform in IPAM, address blocks, address spaces, address ranges, you could use your existing tool or Excel to export it out into a CSV file and then load that CSV file using IPAM. So let's just do a quick demo. There is a full 1-hour session on IPAM. So I'm just going to show you how IPAM looks like, and if you're interested, I urge you to go to the IPAM session. So IPAM is a feature. It's not installed by default. It's something that you need to install once you have your server set up. This is the new beautiful Server Manager UI. And as soon as you install IPAM, it's going to add the IPAM dashboard onto Server Manager. So in addition to managing your storage, you can also storage your networking. You can also manage your IP addresses from within the same window. Again, I've told you that PowerShell is everywhere. Every operation that you could do from the UI here can be automated using PowerShell. In fact, this UI calls PowerShell underneath to perform whatever you want to. So as soon as you install the IPAM feature, it provides you a set of options here. So all that you need to do is just walk through these steps. It has documentation at every stage. So walk through this, you're set. And then it provides, like I said, the server inventory, all the servers that you're monitoring. It gives you the status of each of these servers, the location, the domain that it's joined to, every other information that you care about. The IP address space section gives you all the information that's related to address space management. You, again, have handy little information that you could read through at your own convenience. So you have the ability to create IP address blocks, assign it for the future, saying that, this range, I just want to save it for the future for a new building or a new company or a new branch that I'm going to open. So you can create all these things. And it's visually pretty rich, right? So it gives you an idea as to how well you're utilizing that block or that specific range. Here, we haven't utilized a whole lot of addresses. You have a total of 65,536 addresses. Only 9,000 of them, or almost 10,000 of them have been assigned, and only 777 of them have been utilized. So all these are good, right? And then from the blocks, you can now carve out IP address ranges. Again, the same thing. It says whether it's optimally used or whether it's underused or it's almost up to full capacity. It gives you the percentage of utilization here. And then the good thing is all the regular operations that you want to do are available here. You can export all this onto a CSV file. So if you want to kind of, grow or implement IPAM in your enterprise over a period of time, you could import and export CSVs till you're completely comfortable with it. And then this lists all the IP addresses and the devices that are associated with it. Again, this includes both static and dynamic IP addresses. It lists the device type. You could do further filtering here by just understanding all the firewall machines that you have, and it lists that. It'll again list the status of it, if the IP address is going to expire, or if it has already expired. It's again visually rich. It's going to tell you what's happening there. And this is a section where you manage your DNS and DHCP servers. Again, it's going to tell you whether it's up and running, whether it's updated. You could split IPv4 and IPv6. And finally, your auditing section, right? This gives you a complete history of everything that you care about. So you have the ability to track by IP address, and then now you know this would list you how this specific IP address 10.1.0.2 was used across over a period of time. So it's rich. It has almost all features that you want, and it ships in box. So there is a session, and I have session information listed at the end of the slide deck. So if this is something that you like, go to that session. Or if you don't have time, stop by the networking booth, and we could talk more about it. OK, moving on to performance features and improvements. I spoke about level setting, right? Before I start talking about different things through the performance sections, I wanted to make sure that both of us have a clear understanding of some of the terms that I'll be using throughout this session. So let's just go over some of the terminology that I'll use. Processor, I'm assuming most of you know what it is, right? People call it a CPU, a socket. Intel or AMD servers these days come with 2, 4, or more than that socket machines. So most of you know what a processor is. A node, each processor can have multiple nodes. Nodes are a bunch of logical processors together. And you can also see memory and networking hanging out of a node. So nodes, you can think of it as a bunch of logical processors. And a NUMA node is a bunch of logical processors and the cache that it uses. So the memory associated with those bunch of processors are tied within a particular node. So they are allocated just for that node for quick access. A core, so a node can have multiple core. A core is your central processing unit, and all that the core has is just a bunch of logical processors. And logical processors, you could think of them as threads, right? So typically when people talk about hyper-threaded machines, it means that there are a bunch of logical processors in that particular machine. Kernel group, everything that we've seen so far are all hardware definitions. Kernel group is Windows specific. So if you have more than 64 logical processors, Windows groups it as a single kernel group. So you can have multiple kernel groups depending on the number of logical processors you have. And finally, affinity. Your application, your process, can set an affinity to a specific processor so that the resources of that specific processor is dedicated just to your application. So if you have a line of business application that's running that needs to be up all the time with excellent response rate, you typically affinitize it to one or more processors. Let's go over some performance metrics, right? When you go and talk to a performance architect and then you tell him that, listen, I need to improve the performance of my system, or how do I get the best performance? It's usually an hour-long conversation, right? He's not going to tell you that do this, do that, and you get the best performance that's out there. So let's go over some of the questions or some of the terms that he'll use. Latency. Again, this is pretty familiar to a lot of you. It's just the amount of time that it takes for a particular operation to complete, right? Scalability. This is becoming more and more applicable as we talk about expanding resources, growing into the public cloud, ability to scale. So it's basically the ability to scale or grow whenever your demand increases, right? So higher the scalability, the better it is. For latency, lower the latency, less than amount of time it takes, the better it is. Throughput is the amount of data that's that gets transferred or processed in a given amount of time. So higher throughput, that's good. Path length, you could think of it simplistically as the number of CPU cycles that it takes to perform a particular operation. But the actual value is the number of CPU cycles over the actual throughput that you get. But it's just the CPU resources that you end up using. Variability jitter, it's the fluctuation that you get, right? I mean, we spoke about SLA saying that 99% uptime with this kind of bandwidth, but that doesn't happen all the time. It fluctuates, right? Depending on what other work your CPU is doing, how fast your storage is, there is a fluctuation, and that's called as a jitter. So what I've done here is I have small logos against each of these metrics. And as we go over different features, you would see these metrics listed there. So what that basically means is that that particular feature helps with this specific performance metric. Before we jump in, there's one thing that I wanted to bring up. Some of the demos that I have to do involves logging into the performance lab back in Redmond, and I'm not getting access from here. So I have to switch back to videos. I really, really apologize for that. But the videos are recorded well. They're very informative. But unfortunately, for some of the demos, I'll not be able to do live demos. So let's look at a typical IT pro problem, right? You have a receive-heavy workload that's eating up one of your CPU. CPU is getting hammered at 100%, and you're not able to increase throughput. Think of a typical backup job that's happening. Receive heavy means the server that's getting in the data, right? So it's getting a lot of data, and all the data gets piped up, so one of your CPUs is getting heavily hit. So what would you do to improve the performance? So the feature that helps with that is receive segment coalescing. So with this feature, what we do is, so think about it. You have your client sitting, let's say, in Berlin, and your server is sitting in Amsterdam, right? And they've started a backup job from there, and the data gets backed up in Amsterdam. So the number of packets that come in, the size of each of the network packets that come in, completely depend on the speed of the NIC that they had, the speed of the NIC that you have, and the connectivity in between, right? But every time a packet comes in, it goes up all the way to the CPU. It gets processed, and it gets backed up to whatever location it needs to go to. But what that means is, for every packet, your CPU is actually spending a cycle or more trying to process that. So that's not the most efficient way to do it. So with RSC, what we are doing is we are coalescing multiple packets in one go, sending a big buffer up so that the CPU can process that and then move on. So based on some of the internal testing that we've done, we've seen over a 20% reduction in CPU cycles with this feature turned on. And the good thing is all 10 gig inbox network adapters support this by default. So there's nothing that you need to do. As long as you have a 10 gig network adapter, this feature is on for you automatically with Windows Server 2012. So let's look at a demo for this now.
This is our receive segment coalescing demo. What we have here is a machine running TTCP. It's a primitive networking benchmark. And the two counters that we're looking at are both CPU utilization on the system, overall CPU utilization, and packets received per second. So you'll notice that the dark line, the first dark line, is the processor utilization, which is hovering around 80%. And the packets per second is another counter that we're looking at, which is also running at about 800,000 packets per second received. So in this configuration, this is the out-of-the-box default configuration where we have receive segment coalescing enabled. And that's the last parameter shown in nutshell. So what we'll go ahead and do is to highlight the benefits of receive segment coalescing is we will disable this feature and we will see what the impact is on CPU and packets received per second. So I'll go ahead and I'll disable this guy. And we'll jump back and look at what the performance looks like on the performance graph. So our expectation here is we will see a dip of about 20 to 25% in throughput and a similar increase in CPU. So.
We even simulated a mistake for you just so that it looks like a live demo.
Yep. And sure enough, so the CPU has jumped up to about 100%, and the packets per second have gone down also by 20%. So the CPU is 100%, and packets per second have gone down to about 700,000. And with that, I conclude this demo.
So without any configuration, this is available for you with Windows Server 2012. No, that's not what I want. Ah, come on. So the next problem that the IT pro faces, so you've received a heavy workload that's CPU bound, and you want to scale it so that it uses multiple CPUs that you have, right? Think of, again, a web server or a file server operation. The solution for that is receive-side scaling. Most of you know that receive-side scaling has been there for a while. But what has changed is that in Windows Server 2008 R2, it was profile 0 by default, and in Windows Server 2012, it's profile 3 by default. These are numbers, but I'll tell you why these numbers matter in the next screen. So you could turn on, turn off, change the profile. So the difference between profile 0 and profile 3 is, think of a multi-node system that you have, right? With profile 0, the way it works in 2008 R2 is it uses the processors within a single node. So the rest of the nodes are just sitting there, whereas your first node is working at maximum capacity. So you round robin within logical processors in a particular node, but the other nodes are just sitting. But with profile 3, you're now efficiently using the entire system. So this is how it works with Windows Server 2008 R2. You have a node, it sees node 0, and within the processors in that particular node, it's just rotating. So any packets that are coming are actually waiting till any of these processors get free. But you still have 75% of your CPU resources that are not utilized at all. So what have we done with 2012? We're evenly distributing the traffic across multiple nodes. So the same 8 queues are distributed across multiple nodes now. So you are more efficiently making use of the processors. Again, this helps with TCP and UDP receive traffic. The performance improvements that we've seen with this feature turned on is just incredible, right? So the web scalability has improved anywhere between 50% to 200%, depending on the number of nodes that you have. So if you remember the previous screen, it's equally distributing workloads across multiple nodes, right? So the more nodes you have, the better it is. The hardware we've used for this specific test was a pretty standard run-of-the-mill hardware, right? It has 40 logical processors with 4 nodes, 10 gig adapter, 128 GB RAM, and the workload was a mixed web workload with both static and dynamic data. So with a single process running with just 2 nodes, we saw a 50% jump in scalability. With 4 nodes, it was over 200%, but it's not realistic to have just a single process on your server. So with multiple processors, on a 2-node system, we use 2 processors, and we saw a 43% jump. And on a 4-node machine with 4 processors, we saw a 115% jump. What we ended up doing was affinitize each of these nodes to a specific process. So again, this is available off the shelf for you with all 10 gig inbox adapters. The next problem that you have is a typical issue that you would run into when you're expanding the number of VMs that you have in a specific host, right? There's only a point with your existing hardware. Beyond a point, you'll not be able to add more and more VMs because your CPU is getting hit really hard processing all the packets that it's getting. So for that, we have virtual machine queues. Again, this has been a feature that's been there since 2008 R2, but what we've made is made VM queues more dynamic. So let me just tell you what we've done there, right? Think about packets that come in. With virtual machine queues, or let me just even take queue before that. Without virtual machine queues, right? Every time a packet comes in, the virtual switch tries to figure out, okay, this packet needs to go to this specific VM. Let me just send it over there, right? So every time a packet comes in, your CPU is getting hit pretty hard. But after we put in virtual machine queues, your NIC now has shared memory with your VMs. So your NIC, as soon as it gets a packet, writes to a specific piece of memory, which only that VM has access to. And then the CPU is not involved at all. So the first time the packet comes in, the CPU is involved. It understands that this packet needs to go to this specific VM. If it's this specific header, just reroute it automatically. So after the first iteration, the CPU is free from that point on. So with this, every VM that you have, though you have a single NIC, because it has dedicated pieces of memory for each VM, it thinks that it has an individual NIC that's attached to it. So virtual machine queue did wonders, right? But what we've done with 2012 is made virtual machine queues dynamic. So depending on the CPU workload and the network workload, we switch across multiple processors. So all the advantages that you get out of your virtual machine queue exist, but for packets that need to go up to the CPU, now, depending if you have multiple processors, it checks into account how the processors are getting used, and then it allocates it according to how the workload is. And the good thing is, once the workload comes down, it automatically relinquishes the CPU. Right? So again, without you having to do anything, this feature is available. So what we've seen so far are problems that IT pros typically worry about. For the 3 or 4 developers that are there in this room, I have a couple of features for you. For the rest of you, it's still good information that you could take back to the team. These are good features that you need to be aware of. Let's say that you work for a company that writes stock trading applications or developing a 3D engine where every microsecond is important to you. What do you do about it? So we have a feature called registered I/O that we introduced with Windows Server 2012. So with registered I/O, what we do is we pin sections of memory specifically to that particular process. So think about swapping out memory, swapping in again. All those things don't happen anymore. So you don't have the concept of checking to see if you have to lock the memory and then lock it and then unlock it. So this section of memory is completely dedicated to you. So it gives you, the CPU is amortized much better, so it gives you greater performance. I've listed a couple of APIs that you could use for this. For people who are interested, you could take a look at the slide deck and go read more about these APIs. The second developer problem that I wanted to talk about was sharing messages between different processes that are running in your system, right? A lot of you are familiar with RPC or shared memory. And we also have TCP loopback in Windows 2008 R2. I'll tell you what has changed in this specific feature. So when you have two processors, think of a database application, right, where these processes talk to each other constantly. Every time this guy sends a message to the other process, it goes down the stack and then goes up again into the new process. But what we've done with 2012 is completely cut the path so that all that it goes through is the function driver, and then it directly goes to the next process. Again, we've seen great performance results with this. I'll play you a video. So if you are a developer and you want to make use of it, you have to set the loopback fastpath ioctl in your code. If you don't set it, it'll still take the old longer path. If you set it on both sides of the process, then this feature is available to you. So let's look at a video for this.
This is our TCP loopback fastpath demo. Loopback has been used as an IPC mechanism in the past, but it hasn't been all that great compared to some of the other mechanisms like shared memory or RPC. And the main customer for this scenario really is an application like a database application or some kind of a business application that wants to do a lot of inter-process communication. In Windows Server 8, we feel that TCP loopback is actually a great candidate for this. So what we've done in this demo is we want to demonstrate what the benefits of using the new socket option introduced for utilizing the fastpath and loopback. So what we have here is a version of TTCP where we've added the socket option through a switch. So by adding the switch, we toggle the option on, and by not having the switch, we take the regular TCP loopback path. So on the right hand side here, I'm going to have an instance of TTCP that receives data. We'll be receiving 1 meg buffers using a single thread running on CPU 1. So this machine has 2 logical processors. It's my laptop, and it will be receiving them on the loopback IP address. It will be posting 16 I/O receive buffers, and the test will be running for about 15 seconds plus another 15 seconds for warm up and cool down to make sure that the data is reproducible. So let's actually kick off the receiver. And then on the sender side, it's the same syntax except for the -s to signify that this is the sender. So again, this is the scenario where we're not using the loopback fastpath. And we're going to let it run for 15 seconds, and then we will look at 2 metrics. The first metric is the throughput. How much throughput are we getting going over the regular loopback path? And the second thing is the cycles per byte. So how many cycles, how many CPU cycles are being used for sending that much data over the loopback path? Now excuse the clutter. This version of TTCP is a private version, so it has a lot of data in it. But really the main metrics that we'd like to focus on are 2 of them. The first one is the throughput, where we're running about 300 megabytes per second, and the cycles per byte, which is about 10.4 cycles per byte. So again, with no fast path option, we're getting about 300 megabytes per second at 10 cycles per byte.
So higher
Now
throughput is good, lower cycle is
the
good.
fast path option. So we're going to kick off the help to see what is the option that we need to add. And you'll notice at the bottom that there is a -LFP for SIO loopback fastpath. So we'll go ahead and add this on the receive side first. So we're listening. And then on the send side, we add the same option, -LFP. And then we'll let it run for 15 seconds again, plus warm up and cool down. And then we'll see how the data compares to before. So remember, before we had 300 megabytes per second and 10 cycles per byte. So we'll see what the difference here is. It should be better. And this is a great deal for applications. This is a very primitive benchmark, but you can imagine what you can do with this. You can actually add this by just simple socket option, and bam, you can just double your throughput. So from 300 megabytes per second, now we're getting about 600 megabytes per second, and the cycles per byte are halved. Now, Why is it that the cycles per byte are half and the throughput doubled? The reason is this is a 2 CPU machine and one of the CPUs is maxed out. So we are using the same CPU for both cases, but in one case it's far more efficient because by adding the new option, the new socket option, we are taking a much shorter path for loopback than we were on the previous OS versions. And with this, I conclude my demo and we go back to our presentation. Thank you. This is our TCP loopback fastpath demo.
All right. So a few takeaways for you, right? So if low latency is something that's very, very important to you, these are some recommendations that we have for you, right? So you want to make sure that the jitter is low and your latency is low. What can you do about it? So first thing is disable C states from your BIOS, and then disable all the power management configurations that you've already done. The problem with power management configuration is every time your entire power management module gets loaded up, and there is a significant amount of work that needs to be done every time it comes up and then goes down. So disable that. And then features that, try to reduce the CPU cycle, like RSC, RSS, you can disable it. Again, if you go back to the list of performance metrics that we spoke about, and if you try to map all those metrics to each and every feature, so you can mix and match depending on what kind of workload you have and what kind of metric is important to you. There is a detailed white paper that we've written. The link of that is given here. So you could read more about it, and it'll have more information about why we've made these recommendations. Performance analysis and tools. So let's look at a couple of ways where you could monitor your performance and turn on, turn off the features that we spoke about in the previous slide. Server Performance Advisor, it's not new. I'm assuming that a lot of you are familiar with it. We are revving it with Windows Server 2012. So Server Performance Advisor 3.0 is now available for download. It's a free download software. It's a very thin software, and it lets you basically diagnose performance issues within your server. So your Server Performance Advisor SPA typically has multiple advisor packs, and each advisor pack has a bunch of rules. So you can, and what you see here is one specific rule for network packet retransmit rate. And then it says whether it's enabled or disabled. You could enable or disable it anytime after you install it. And then what it does is it runs over a period of time and then gives you a specific recommendation. In this case, it's found that the packet retransmit rate is pretty high, and it's telling you why it's high and what you could do to fix it. I have another video demo of this, which I think most of you would find really useful. So again, it's a very thin file. Installation doesn't take a whole lot. It gives you side-by-side comparison charts that you could use. For example, you want to compare the performance during day and during night to understand how your, for example, your center on the other side of the world uses the resources versus how you use it. So it gives you the ability to compare and contrast different sets of data. So let's just take a look at the demo. And this, I think, is applicable for everyone, no matter whether you're a developer or IT.
This demo demonstrates how a user can use the Server Performance Advisor tool or SPA to diagnose network performance problems. What we have here is a simulation of a TCP running in the background. This is again going over loopback. So we're going to run this guy for a long time, and what it simulates a server that's under heavy network pressure. One of the CPUs is maxed out at 100%, but we're going to assume that the user doesn't really recognize why their customers are complaining that everything has just gotten much slower. So the user can launch the Server Performance Advisor console after they install it, And Server Performance Advisor, or SPA, has already been published on the web, and folks can get it online. And I'll be sharing the link for getting SPA online for free at the end of the presentation. But for now, I've just downloaded it on my laptop. I've installed SQL Express, which is necessary for storing the data and the reports. And what I've done here is I've kicked off the SPA console. You'll notice that Talat XPS is the name of my machine. I haven't collected any reports thus far because I was waiting to go through this with you. And so I'm the user now, and my customers have told me that they're experiencing some issues, some networking issues, and I'm going to try and diagnose, or at least have an idea of what's going on the machine. So the first thing that we want to do is we want to select the server, which has already been selected. We can go in the configure advisor packs. Advisor packs in SPA are like plugins, and we're shipping 3 of those. There is the IS advisor pack, there is an Hyper-V advisor pack, and a CoreOS advisor pack. Each one of those packs contains rules and thresholds. So if we go and hover over the Core Advisor pack, CoreOS advisor pack, and we click configure, you will see a lot of storage and CPU and memory and all the fundamental resources of our operating system. But the focus for this case, or the complaints from customers, are networking specific. So we can go and look at things like, do I have 64-bit capable adapters? Is there an endless TPC bottleneck on one of my CPUs? Am I seeing receive packet drops? Are all the offload capabilities of the NIC enabled? Are there any TCP connection failures? And one other one that's important is also the average CPU utilization on any node. So by selecting average CPU utilization on any node, I can actually open it and I can look at what the threshold settings are. These are settings that we have shipped with SPA based on some of the lab data and some of the work we've done internally to Microsoft, but those by no means are set in stone. A customer or a user can actually go in there and change them, just like you see here. The original setting was set to 80%, so if the CPU goes above 80% on one specific node in the system, then the rule fires. But I've gone ahead and I've changed it to 40%. And then we close this guy, and then we can go back and we can say, now I want to run some analysis on my machine. So when I click the run analysis, I get to choose which advisor pack I'd like to use for assessing the health of the server. So I'm going to choose the CoreOS advisor pack because it has the most representative networking rules in it. I will say OK, and then now it's in it. What happens is SPA goes across to the server, or in this case it's running on the same machine, and it starts collecting a whole bunch of perf1 counters, WMI class information, ETW information. And for those of you who don't know what ETW is, it's the event tracing in Windows. It's very rich in context and very helpful in analyzing and identifying performance problems. And it also goes and checks the registry for some specific performance related registry information. So we'll let it run for a while. The default is 60 seconds, just to make sure that we do have enough information to make a good assessment of what the machine is experiencing. And we'll let it collect the data and import the data, and then we will be presented with a report. So while this runs on the server machine, which is great, it offers a lot of functionality, as you will see. It has like a report view, it has a graphing view, it has a side-by-side view. And we've done a lot of presentations in the past, actually a video and a couple of presentations around using SPA. So if you'd like, you can always go back to some of the TechReady and some of the TechEd slides, and even the Build slide conference, where we've done some talks about SPA if you'd like to get more information. So now it's done. It's importing the ETW trace information and some of the perf1 counters, and it's generating the reports. In this case, it's just a single report that we were going to get for our server or running on my machine here.
Come on.
So there it is. So we have a report that has some warnings. So we click on the warnings, and we see that we have 3 warnings. The first one is available disk space. So I'm running out of disk space in the box. Average CPU utilization on any node is above 40%, and my network adapters are not 64-bit capable. Well, that's explainable because I'm running on my loopback. So let's actually go and look at the average CPU utilization on any node. So you look at the top and you see that there's CPU, memory, disk, network. So if we click on the CPU tab, it gives us some CPU information at the top. If we scroll further down, we go to statistics. We'll notice that the total processor time, 90% of the time was 75%, and the average was about 74%. If we dig further, we'll notice that CPU 0 was running at about 75% total on the single node, because this is a single node machine. And on this one, I have 2 CPUs, 0 and 1, on node 0. One is running at 50% and the other guy is running at 100%. So it looks like my CPU was running at 100% and is unable to process any more incoming requests, which is why my loopback throughput will probably be capped, because there are no more CPU cycles to push throughput any higher. Another warning was the available disk space. So for kicks, we can go in here. Again, it gives you some information about my physical disk, logical disk, and then you'll notice that on my E drive, 99% of my E drive is being utilized. So again, it really flags this. For example, if I'm writing to a log file on E, and if I'm getting some failures, then this will tell me that, hey, because you're running out of space on E, that's why you're getting those failures, or that's why you're getting less performance, because you have to deal with some error paths. So the key takeaways from this is, I totally encourage you to use SPA for diagnosing some of your performance problems. SPA will not tell you exactly what the issue is, but it will at least provide you some guidance on what some of the anomalies and some of the weird things happening on the machine, so you can go ahead and make the intelligent decisions to enable certain features or to further diagnose the problem. Thank you.
All right. And we've added a whole bunch of performance counters that are available using the perfmon tool. So because we are NUMA aware now, there are counters related to NUMA node. There are specific counters related to processor performance, how your network adapter is performing, and specifically RDMA, right? I don't know how many of you are familiar with a new feature that we've added called RDMA. There is a separate session on SMB Direct, which is RDMA. So what we are doing now is, when you think about the file copy operation, right, between your client and your server, like I told you, every time your data gets copied, your CPU reads the data from your disk location, and then it goes down the networking stack to your NIC, and then from there on to another NIC, and then it goes up again, and then it decides this is where the data needs to be transferred, right? With SMB Direct, a new feature in Windows Server 2012, what we are doing is issuing a token onto your NIC. And after that point of time, when the data gets transferred, only the NICs talk to each other. The CPU and the rest of the stack aren't involved at all. And we get great performance. You can compare it to fiber channel-like performance depending on the speed of your NIC. But this is an awesome little feature that we've added in Windows Server 2012. You can get information about that with perfmon as well. PowerShell, all the features that we spoke about over the last hour or so, all of them can be turned on or turned off using PowerShell. We mentioned setting the RSS profile. That can be done. And there are features that are, there is a feature called SRIOV. Most of you are familiar with it. For the ones who aren't, it's again very similar to what I spoke about now, where NIC directly talks to your VM as opposed to going through your virtual switch. And then again, it doesn't use your CPU resources. So we'll go into SRIOV in detail in the networking overview session, but that's again a good feature that you should be aware of. So almost everything is configurable using PowerShell. Enabling, disabling features, that can be done using PowerShell again. So according to me, this is kind of the Bible with respect to Windows Server 2012 and performance, right? So on the left here, it talks about all the metrics that we spoke about over the course of this presentation. And on the column, on the row on the top, it talks about different performance features that we have in Windows Server 2012 and what it enables. So for example, latency, loopback fastpath, we saw about it, that helps with latency. RIO helps with latency. RDMA and SRIOV helps with latency. So this is a printout that you typically need to have with you to make sure that you either control it with PowerShell depending on what kind of workload that you have over a period of time, or just use this to turn on or turn off for once, and then it's run after that point of time. So this kind of summarizes everything that we saw over the last hour. So in conclusion, so I think we walked through a few performance-specific features that are new with Windows Server 2012. I haven't covered every feature that's specific to performance. There are more features that were added. We've blogged about it in detail. There are other sessions where we'll talk about pieces of that. But if you haven't downloaded Windows Server 2012 RC yet, I would recommend that you do it, play around with it, understand it more. And almost all the features that we saw today are available in box, right? We are not asking you to buy additional hardware, additional NICs. So if you have a 10 gig in-box network adapter, almost all the features that we spoke about are available to you. And if you're a developer, some of them are just adding additional socket controls. Some of them are using a different set of APIs, just that you have additional choices to improve performance. And then we also walked through a couple of new features that we've added in network management. There's a session on IPAM, so if you're interested in IPAM, if you're still using spreadsheet to manage your IP address lifecycle, go for that session and then know how you could use it in your organization. And we covered a couple of tools that we could use to fine-tune your performance. Yes, that's pretty much it. And these are the sessions that I think you should be taking a look at if you're interested in networking, and all the work that we've done in Windows Server 2012 with respect to networking. Guess that's pretty much it. If you have questions, I'm here, or we have a networking booth you could stop by. We have the evaluation guides. If you like the session, please fill it in. If you don't like it, still fill it in, but let us know what we could do in this specific session that would make it more beneficial to you. Like I said, performance is always tricky. A lot of people like it. They get it instantly. For a lot of people, it's Greek and Latin. It doesn't make much sense. We've tried to list typical problems that people see and address features related to that, but your feedback is really welcome. We'd appreciate it. Thanks a lot for spending time with us. Thank you.